In the beta decay that we've been talking about, there's an electron emitted, which electron, so what? But this neutrino in the beta decay for minus beta decay is an anti-neutrino. Now, I haven't really focused on what an anti-neutrino is. Why is it an anti? And neutrinos are actually part of matter, so it's like an antimatter particle. What's going on there? Why is it called an antimatter particle? Well, I kind of brushed over the fact that it's a neutrino going backwards in time. Now, does this mean we can have time travel and we can go back in time? If matter is can go back in time, then our bodies can go back in time? I'm not going to make that big a stretch. Not yet. But why do we say, or why did not we say, but the physicists say that it goes back in time? Because of the fact that when they do the math, the only way they can get the math to work out is for it to be the time to be in the reverse direction or time to have a negative value. Now, the Feynman diagram has an arrow going the other direction, which is why we say that that happens. But beta decay is not only minus beta decay, it can be plus beta decay. So what's the plus sign for? Well, the plus sign is for a plus charge, and in plus beta decay, we see the particle being deflected in the opposite direction of a negative particle. So it must be a positive particle, and therefore it's called a positron. You could call it an anti-electron. You'd be just as accurate to do that. So, what does this mean if it goes backwards in time? Well, somebody theorized, in fact, John Wheeler, who was one of the people that advised Richard Feynman when he was in at Caltech, that if it can go back in time, then we're actually creating an electron positron pair, and that might mean that every electron that's out there is just a electron that was created from an original electron. And they came up with this idea of one world electron, which means that all these electrons are around, and electrons obviously are super plentiful. All the electrons around were created from from an original electron positron pair, because the electrons like going back in time. Now, is there anything else like that? Well, why don't they say that there's a single neutrino pair, a neutrino and an antineutrino? Well, the reason why that one doesn't qualify is that if you recall from my last video, that neutrino, electron style neutrino that's created, or antineutrino, it oscillates between the other two flavors, a muon and a tau flavor for that neutrino. So neutrino doesn't fit that period. But what about a quark? Well, quarks make up protons and neutrons, and there can actually be an anti-quark. And because of this, you can have we've got an up quark and a down quark, but we can have an up anti-quark and a down anti-quark. And all of these quarks could be from an original quark. So let's start the universe. I've got an electron that it's creates an electron positron pair through some big energy influx. Now remember, when the electron and positron meet, they annihilate one another, and there's a big energy expended. So there has to be energy that's expended when we create this electron positron pair. So the universe could have been started by one electron, one up quark, one down quark. Huge amount of energy. Call it the Big Bang. I haven't really talked about Big Bang because that just thing is too popularized, and unless we come up with some more uh, physicist type descriptions, we're not going to go there. Let your mind go now and imagine that the beginning of the universe, and I've got one electron or one electron positron pair, one electron, one quark pair, quark and antiquark pair, and create the whole universe. And the neutrino is always elusive. Where does the neutrino work out in all this? It You got to start somewhere. And was the neutrino around originally? I don't know the answer to that. So ponder on this, and I'll get back to you with some more weird information.